Welcome back with another exciting video. In this video, we will discuss the rate limiter. So first, coming on to the functional requirements, we'll satisfy two functional requirements in this video. So first, the functional requirement is limit the number of requests per user or per IP or per API key. The second requirement is reject requests once the limit is exceeded. We'll satisfy these two functional requirements in this video. And non-functional requirements are low latency and high availability. So let us estimate the capacity. So normally rate limiters are memory heavy, not storage heavy. So let us assume 10 million daily active users. So for each user we store a simple counter which has user ID, count and timestamp. User ID, let's say it takes 8 bytes, count takes 4 bytes, and timestamp takes 4 bytes. So totally it's approx 20 bytes. So memory needed is 10 million users into 20 bytes is 200 MB. So conclusion from this is we can easily store all counters in memory. So we don't need any hard disk. So Redis is perfect choice for this rate limiting. So the database design for this is first one rate limit counter. We'll store it in a Redis cache. So it contains the key as user ID, value as the limit, and TTL time to live is 60 seconds. After 60 seconds, it gets deleted. So how to increment the value? When we use this, we can use this command increase rate limit user 1234. It increase the value from 25 to 26. When the user is created, we set the TTL. How to set TTL? Using expire rate limit user 12345 60. When you use this command, TTL is set to 60. This is what gets stored in Redis cache. The other database is rule DB. It uses NoSQL, so it stores the user ID, user type, and user, like whether he is using free tier or paid, and the API, the number of limits, window size like 60 seconds, and the algorithm. We have token bucket. We have token bucket, uh, window, and also leaky bucket. We have 3 to 4 types of algorithms, so it defines which type of rate limit algorithm to use. This is rule DB. Coming on to API design, uh, get rule get rule with user ID. Using this API, it queries the rule DB and gets the rule. The request is this, and the response we get is this. After getting this, we update and get rate limit from the Redis cache. We update the value to value plus 1 and also get the current value. We will compare the current value with the limit. If the current value is less than the limit, then the query goes to backend server, or else we reject the query. Okay, let's see high level design. So first the user sends the request to the backend server. The request goes to the rate limiter. The rate limiter sends two API queries. One is get rule with user ID, and the other one is get and update rate limit. After getting the rule and after getting the limit, the rule contains the limit. If the value of this limit is less than the rule, then the request is forwarded, or else the request is rejected. So this satisfies all the functional requirements. Coming on to non-functional requirements, we need to satisfy two of them. One is low latency and the other is high availability. To satisfy low latency, we are using Redis cache, which satisfies low latency. And also, uh, let us use another cache, rule cache, because for every rule get rule with user id. For every API, we can't query in the rule database. What we will do is we'll use rule cache. It stores the frequently accessed rules. So it stores the frequently accessed rules instead of uh, instead of every time asking Redis, rule DB will ask rule cache. We uh, will ask in rule cache. Get rule with user ID. If it is present in rule cache, then it returns the uh, then it returns the rule associated with particular user ID. If it's not present, then it has the rule DB. So this reduces some of the latency. And also we need high availability. So what we do is we replicate all of these, so there's no single point of failure. So we'll duplicate all of these. So if one server fails, another stays. One fails, another stays. And also we'll replicate the database, because if this database get failed, then other then complete server get crashed. So let's replicate the database. Same even for this, we'll replicate the database, rule database. Yes. So it satisfies low latency and high availability. So if you like this video, please consider like, share and subscribe.